Hi, my name is Rachel Davidson, and I'll be talking about the performance of Lifelines in the Nepal Earthquake and Aftershocks. I'd like to first acknowledge my collaborator, Chris Poland, who was with me for the entire reconnaissance trip and helped put together this presentation. I'd also like to point out that this is just one of a series of briefing videos related to the Nepal earthquake that EERI is putting together, and I encourage you to go look at the rest of them as well. What I'll be doing today is talking about each of the lifelines in turn. For each one, I'll describe a little bit about how it was functioning before the earthquake, and then talk about the effects of the earthquake on that lifeline. So I'll start with electricity. About 800 megawatts of electricity are supplied each year, almost entirely from hydropower. That represents about 2/3 of the actual demand for electricity, though. So load shedding is done extensively for the other 400 megawatts, which means that some customers are without power for up to 12 hours a day. So to meet this substantial shortfall, the Nepal Electricity Authority has been importing power from India. That's quite expensive, though, so they're trying to cut back on that. They're also, over the long term, have several hydropower projects underway through which they hope to more than double the capacity of the system over the next several years. In the meantime, though, customers have developed their own workarounds to deal with the load shedding. Many customers have powers or even their own generators, particularly hospitals, hotels, and critical facilities, but also just normal customers as well. So there was substantial damage to the electric power system during the earthquake that's listed here. For the generation, most of the damage was to the projects that are under construction as opposed to the ones that are currently in operation. For transmission, a couple of towers fell, and there was also a lot of damage to the distribution lines, particularly in areas that had a lot of building damage. A lot of the damage was caused by landslides, but nevertheless, the power was mostly restored within 1 to 7 days. So because of the normal load shedding, as I said, most customers had their own backup to deal with that. So the effect on customers was somewhat limited because of that. Nevertheless, there's a large expense now to repair all the damage. For the existing system, they estimated about 5 billion Nepali rupees for the government-owned infrastructure, and there will be additional expenses for the privately owned. For the hydropower projects under construction, they estimated they would all be delayed by about a year at least. So there will be a lot of lost revenue due to those delays. Some of that loss is insured, but not all of it. So the effect is still important in delaying the ability of Nepal to meet the electricity demands for the coming years. For the water supply system, there are two different agencies. One, KUKL, supplies water within Kathmandu Valley, and then another, the Department of Water Supply and Sewerage, provides water outside of Kathmandu Valley in the districts. So I'll talk about each in turn. Within the valley, there are 8 subsystems. You can see in the map on the lower right here. These main trunk lines bring water to the center of the city. The pipes were originally cast iron and then ductile iron. Some of the newer ones are PVC and HDPE. So some of the older stuff is quite vulnerable. The system also has about 70 deep tube wells that provide water within the city. It all comes from within the valley at this point, but it is only partially treated. Not all customers get treated water all the time. So they have 2 major challenges even before the earthquake. Like electric power, they're unable to meet the full demand for water. So KUKL only provides about 25 to 40% of the demand for water, depending on if it's the dry season or the wet season. You can see in this figure to the right. That means it provides only intermittent service to the customers. So for some customers who happen to be close to a source, they might get water 24/7, but for others, it might be as little as 1 or 2 hours a week. So this map down on the bottom right shows different regions within the valley, the schedule of when they get water supplied. So each color will be a different schedule of when their water will be turned on. They do use tankers to supply extra water as well. But again, customers have developed their own workarounds to deal with the intermittent supply. So many have dug their own shallow wells on their property, and then many also have tanks on their roofs to store the water. So like in the figure up here on the right, the photograph shows these black tanks on the roof. Those are ubiquitous, where people store water during the time when it's turned off. The company has two major development projects to try to deal with this insufficient supply. The Malamachi water supply project will bring water from outside the valley and double the ability to supply water, adding about 510 million liters per day. The Kathmandu Valley Water Supply Improvement Project is also improving the pipelines and the reservoirs, adding a lot more pipes and reservoirs to the system. And those are both ongoing projects over the next few years. They've been delayed multiple times, but they're well underway. The second major challenge they faced even before the earthquake was because of all the wells that KUKL has dug, as well as that private customers have dug, the groundwater is being depleted, and the water table has gone down about 30 meters in the last couple decades. There have been some pilot projects to try to recharge the groundwater, but it's difficult because of iron in the water. So in the earthquake, there were a lot of pipe breaks, especially near the house connections. One of the 8 subsystems had a trunk damaged by landslide. There was some changes to the water table, some silting of wells. A lot of the office buildings were damaged. Loss of power was not a big problem for the water supply system because they're used to the load shedding and had backup, and electric supply wasn't interrupted for very long. So they were able to restore water service within about 1 to 10 days. Again, the effect on average customers was limited because they're used to the supply being intermittent anyway, and also because many people left Kathmandu Valley after the earthquake, so that reduced the demand. Nevertheless, there is a huge price to pay to repair all this damage. They estimate about 210 million Nepali rupees. A lot of that, however, is to repair the office buildings for the agency. For water outside of the valley in the affected districts, the rural areas, there had been a major effort in the last couple of decades to try to meet the Millennium Development Goals and provide access to clean water for everyone. So they had increased their coverage from 37 to 80%. Those are mostly small systems, spring or stream source gravity-fed systems, not usually treated. They serve about 1,000 to 1,500 people per system and are managed by local water user groups. So these systems were very heavily affected. They estimated about 40% of the systems were damaged. Intakes, tanks, pipelines were damaged mostly by landslides in the rural areas. In some places, sources were depleted, and others they were increased. It's not clear if those will be permanent changes or not. As of May 26th, a month after the earthquake, they estimated there were still about 20% of people without access to protected water source. So the effect was, since there wasn't much redundancy in these areas, the effect was that there were fewer taps providing water. A lot of water was being brought in by tanker truck, and as a result, people are having to walk long distances to get water. The photograph on the right shows us talking with some people in the community of Ramkot on the western edge of Kathmandu Valley, and they were explaining that the community up the hill from them had lost its water supply, and so people were walking an hour down the mountain to get water in Ramkot and then walking an hour back up. So those kind of situations are not uncommon now. For wastewater, there had also been a big push in the last couple decades to try to meet the Millennium Development Goals and improve sanitation coverage. There have been a lot of progress on that front. There's still sewage is typically discharged into rivers or septic systems in rural areas that use latrines. And they do have a major improvement project for Kathmandu Valley that's in the design phase, but it's not as far along. And in general, the sanitation didn't seem to be as high a priority as water supply. For communications, there are 6 providers in the country with overlapping service areas. Most people have access to cell phones. All the villages have some communication as of a few years ago, but they're still expanding their service. they have a lot of towers on buildings like the one shown in this photograph. In Kathmandu and the surrounding areas, the system is mostly fiber network, and in the remote areas, mostly microwave. So some of the mobile towers were damaged. They were anchored to the rooftop, so you can see here this building is leaning significantly on the neighboring building, but the tower that was anchored to the top is still in place and is still functioning in that position. So some of the overhead optical fiber lines were down, some microwave links were down. There was some electric power interruption. They did have batteries in place for the normal load shedding, but that didn't last long enough. The figure on the bottom left here shows the percentage of towers that were in operation, so they lost about 20%, and they were mostly repaired over the first couple weeks. So they estimated about 90% of the system was restored within 2 weeks. There were some delays in the response because of not having enough helicopters to get to the remote areas, but in general, operators had spare parts, and they said it was easy to import more when needed. They did mention that they were able to give satellite phones to rescue teams, that they had received those satellite phones during an earthquake preparedness meeting just a couple weeks before, so that was fortuitous. Interestingly, there have been a lot of requests to have the rooftop towers removed because people perceive them as being dangerous or contributing to building damage somehow. So that's an issue that the Nepal Telecommunications Authority is dealing with now. They have several plans in place now as they respond and recover from this earthquake, where they're trying to build back better and improve their earthquake resistance for the future, and those are listed here. For transportation, there's one major airport that serves Kathmandu. It's on the eastern edge of the city, the Tribhuvan Airport. It was closed for inspection and to assemble operating personnel. It reopened within a couple days and was operating then 24/7 with help from the Army and police. All civil aviation flights were canceled for a couple weeks, but all other domestic airports remained open. The runway capacity limited the weight of the landing, so some of the large cargo planes had to partially offload in Delhi. They also had a limited number of parking spaces for the airplanes, and so that also limited the number of landings they were able to have. And there was some insufficient number of custom agents that slowed a little bit of the relief as well. But nevertheless, there were response plans in place for the airport, and they were exercised. And some damage that they thought might occur to the runways didn't happen, so that was good. For roads, again, there are two agencies. There's the Department of Roads is in charge of all the strategic roads, the larger ones and the ones that are considered strategic importance for the country. And then the local municipalities manage the local roads. Many countries have helped build the East-West Highway, which is one of the main highways in the country. They're used to experiencing landslides during the monsoon season, so they have some experience clearing landslides like that happened in this earthquake. Because of the incredibly steep terrain, especially in the northern part of the country, you can see in this photograph here, there are roads that sort of wind around the mountains, have switchbacks and stuff. So because of that terrain, there's not a lot of opportunity for redundancy in the network. And they're really still building out the road network and trying to improve the roads that they have. You can see from the pie chart here, even the strategic roads, which are the bigger and more important ones, only about half of them have blacktop currently before the earthquake. So there was a lot of effect on the road network, a lot of damage due to landslides and ground failure. No bridges collapsed, although there were some small problems. They did not have a particular plan in place, although they did have some experience with landslides during the monsoons, as I mentioned. After the fact, though, they created teams and deployed them to clear the roads. They had 9 heavy equipment divisions throughout the country, and so those were all mobilized along with some private equipment. The Nepal and Chinese armies both helped. For example, they prioritized the roads. For example, the red lines here show the roads that had earthquake damage. This is Kathmandu here. So there's this major road that goes to China and is important for trade. This is an example of one that was a high priority road to clear. But they said that by early June, about 6 weeks after the earthquake, most roads were open. The roads that were blocked did not typically have utilities along them, co-located along them, and so there wasn't a lot of interdependencies between road damage causing utility damage that sometimes happens when there's pipes buried underneath roads. So the summary thoughts, within Kathmandu Valley, the immediate effect of lifeline interruptions on the consumers was smaller than it might have been because they're used to the limited normal service, to the load shedding in the electric power system and the intermittent service for water supply. They already had backup systems. Nevertheless, the damage that was caused is going to cause severe delays in the ongoing development that's been happening in Nepal, and that's unfortunate. If we look at the total loss from the whole event, it was about 6.7 billion US dollars, about a third of the country's GDP, and about 10% of that was associated with these 4 lifeline sectors. So it's a significant cost to repair the damage. The effects are arguably worse in the rural areas because there's limited redundancy, so people having to walk long distances to get water, and that tends to be women and children more often than not, so that's a big concern at the moment. There was not a lot of discussion about interdependencies among lifelines being a problem because the electricity was restored fairly quickly, and because the roads, as I mentioned, the roads that were blocked didn't typically have utilities co-located with them. We didn't hear a lot about preparation for an earthquake ahead of time, but all the agencies talked about ways in which they're trying to build back better now during the recovery process. The landslide risk was pervasive and a really important cause of damage. And there's a lot of concern that the monsoons, which have started now, are going to exacerbate the damage and delay restoration further. And finally, with so much development going on now, so much investment in infrastructure that's happening with these big hydropower projects and water supply projects, it's really important that they develop those projects in a way that's considering earthquake risk, so when the next event happens, they will have improved the resilience and reduced the vulnerability for the next event. So I have some references here for more information, but I also want to point out that there's a lot of great information and photographs on EERI's Virtual Clearinghouse website. And finally, I'd like to acknowledge the many people at different utility agencies and district, city, and ward offices who met with us and provided valuable information and insight. And last but not least, some of these individuals listed here who were very important in providing support for this reconnaissance trip and developing this presentation. Thank you.